In today's notes, we're going to be talking about linear functions. So we're going to be discovering the slope-intercept form. And many of you guys have seen slope-intercept form before. Our learning target today is given a linear equation. So equation meaning you're going to see an equal sign. You want to be able to create a table, so something that looks like this, x and y, and a graph, and we're graphing lines, so they're going to look like that for the equation. All right? So first I want to talk about the parent function of linear functions. The parent function, you can think of the parent function a lot like the parent of a child, okay? So a parent might have multiple children, and all those children have similar attributes as that parent, as that mom or dad. So we talk about the parent as like the most basic linear function, and then every other linear function from there is transformed from that parent function. So they have similar characteristics. So that parent function, we're going to call f of x equals x. You could just say y equals x, but I'm going to use f of x equals x to practice function notation. All right, so I want to create a table for this function. To create a table, we're going to make a table, and some of you guys have seen this before. We have our inputs, we have our outputs, or our y's, and then a function I'm going to put in here, f of x equals x. So I'm going to choose some x values. I'm going to go from -3 to 3. So now I have this function. Well, I just substitute in -3 wherever I see an x. So I'm doing f of -3. Well, that will equal -3. Just replace it. F of -2 will equal -2, and so on. Go ahead and pause the video right now and fill in the rest of this table. Now that you've done this on your own, I'm going to do this quickly here. So the output is just -3, -2, -1, 0, 1, 2, 3. Now go ahead and plot these points on the graph on the right. Pause the video and plot the points yourself. Now that you guys have plotted the points, I'll plot them as well. So -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. Now we only have these points, so we could connect the line at this point, but we chose these points, these x values, means we could have kept going in the table either up or down. So really, if we want to continue this pattern, I say go up one, right one, and I can keep this pattern going and continue graphing this parent function. So we don't have to stop just because our table stopped. Now I like nice straight lines, so I'm going to use a ruler to draw this nice straight line. So now what I would like you to do is pause this video and find the slope from both the table and from the graph. Find the slope from the table and the graph. Now that you've done this on your own, I'm going to talk through this. I know slope from a table is the change in y, so I say I'm adding 1, adding 1. So each time the y coordinates are increasing by 1, as the x coordinates also increase by 1. So my slope will be equal to the change in y, which is 1, over the change in x, which is also 1. So 1 over 1 is equal to 1. Or I can go from my table, from my graph. Let's choose this point and this point. I rise 1, 2, 3, 4. I run 4, so I could think of my slope as rising 4 and running 4, but that still simplifies to 1. So my slope over here, I'm going to highlight in blue because I did that in blue, my slope is equal to 1. Now find the y-intercept from the table and from the graph. Pause the video and find it now. Now that you found it on your own, I'm going to find it myself. On the graph, I know the y-intercept is where the graph crosses the y-axis. That's right here. And on the table, I know it's where x is 0. So that would be right here. So I see my y-intercept is at the origin here. And here we have it in the table. So it is 0, 0. And I'll highlight in orange the y-intercept. All right, so let's do another function. This is not going to be the parent function. I'll say g of x is equal to, let's try 7 minus 2x. What I want you to do right now is just make a table for this function. So we have our x values. Let's choose -3, -2, -1, 0, 1, 2, 3. Our function, g of x equals 7 minus 2x. And then whatever that ends up being, our output. So our inputs and our outputs. Go ahead and make the table right now and pause the video. Now that you've done this, let's check our work. So g of -3 equals 7 minus 3. I substituted a negative, that should be minus 2. Now when I simplify this, -2 times -3 is a positive 6. 6 plus 7 is 13. Over here, g of -2 equals 7 minus 2 times -2. -2 times -2 is a positive 4. 4 plus 7 is 11. G of -1. 7 minus 2 times -1. Got to remember order of operations. -2 times -1 is a positive 2. 2 plus 7 is 9. And I can continue doing this. Until I finish making the table. So I have this table here. Now I'll go ahead and plot these points. When x is -3, y is 13. Oh, that doesn't fit on my graph. When x is -2, y is 11. Also doesn't fit. So let's jump to here. -1, comma 9. 0, comma 7. 1, comma 5, and I can kind of already start noticing this pattern. I'll start graphing it like this. 3, 1, now I can continue the pattern. I don't just have to stop just because my table stopped. If I continue that pattern, we get that. I'll take my straight edge, my ruler, and draw in the line. Now go ahead and do what we did before. Find the slope, I'm going to do this in blue, and the y-intercept, both in the table and the graph for me. Find it in the table and the graph. Pause the video and do this on your own right now. Alright, now that you've done it on your own, go ahead and check your answers with me. So my slope, I know in a table I look for the change in y and the change in x. I notice that we're going down by 2 each time, which means we're subtracting 2. As x increases by 1. So my slope from the table will be the change in y over the change in x, which just simplifies to -2. So my slope is -2. In the graph, I can pick any 2 points. These 2 points here, I go down 4, right 2. So my slope would be a -4 over 2, or -2. The y-intercept is when x is 0, so right here, or where the graph crosses the x-axis, or sorry, y-axis, so right there. So both of those coordinates are 0, 7. So either way I could find that y-intercept. This leads us then to slope-intercept form of a function. You guys have studied slope-intercept form before. We got y equals mx plus b. This is the first of 3 forms of linear equations that we're going to study. Here, we need to figure out what are m and b. So I want to look at this and say, well, where did we see the slope? We see the slope in the table and the graph, but where do we see that in the equation? Well, when you look at that, that's the number in front of x, -2. And where did we see the y-intercept? Well, that was the number that's not next to x. It's the one that's added or subtracted, that doesn't have the variable next to it. So when you look at that, your slope is the coefficient of x, and your y-intercept is the constant term, the one that's added at the end. Okay? So here, let's draw a little arrow. M will represent the slope. Note, it is just the number. It is not the x. So if I were to ask you for the slope, you wouldn't say, in this case, negative 2x. You would just say negative 2. Okay, so it's the slope, just the number, not the x. And then this guy right here gives you what the y-intercept is. The y-intercept is 0, comma, b, whatever that b value is. So I want to ask you a couple questions. Example 1. I want you to write the equation of the line with a slope of 10 and a y-intercept of 0, negative 3. Go ahead and do this one on your own right now and pause the video. Now that you've tried this one on your own, let's talk through this. Well, we have y equals mx plus b. Our slope is 10, so that's going to be this guy. So y equals 10x plus our y-intercept is 0, negative 3, which means b is negative 3. So negative 3. We're not going to write it like this, though. When we add a negative, that is the same as just saying 10x minus 3. So this is how I want your final answer. Next example, example 2, I want you to identify the slope and y-intercept of the equation. So last time I gave you the slope and the y-intercept, I wanted you to write the equation. Now I'm going to give you the equation, and I want you to identify the slope and the y-intercept. So we have y equals 2/3 x minus 7. B, f of x equals 8 minus 7x. C, y equals x plus 7. And D, g of x equals 3x. Go ahead and find the slope and the y-intercept for each of these right now. Pause the video and try this on your own. Now that you've tried it on your own, let's go ahead and identify the slope and y-intercept together. The slope for this first one will be the coefficient of x. So in this case, that would be 2/3. I'll circle it in blue just like I did in the other problem. So the slope would be 2/3. The y-intercept is the constant term, the one that's not connected. Realize that it should be 0, negative 7, not just 7. So that minus means that it's a negative 7. The slope in this one, remember, is always the coefficient of x. So that negative stays with that 7. So this one has a slope of negative 7, and the y-intercept is 0, 8. It's that constant term, the one without the variable. Down here, the slope is always with x. Well, we don't see a number there, so we're thinking, well, what number is the coefficient of x, or what are we multiplying x by if we don't see it? Well, that number is 1. So here, the slope is 1. So if we don't see it, the slope will be 1. And then the y-intercept, wow, we got a lot of 7s here. The y-intercept is 0, 7. Over here, the slope is the coefficient of x. The slope would be 3. And the y-intercept, well, I don't see anything added on at the end. So my question is, what's being added at the end if you don't see anything? Well, when you're adding something and it doesn't change the value, it's plus 0. So we have 0, 0 is the y-intercept. Now when you look on the back here, we're going to discuss these transformations tomorrow in class. So don't worry about that too much. You're not going to fill that in. What I want to do instead is have you be thinking about what's going on here. Is creating the table and the graph. So what I'd like you to do next is take out the 2B1 homework, and you're going to make tables and graphs for all of those functions. So make tables and graphs for each one of those functions. When you do that, I want you to also graph the parent function. So for example, if this was one of my homework problems, I'm also going to graph the parent function. So the parent function was y equals x. That's this guy right here. And you're going to get really good at graphing this parent function. So we can compare the graph of any equation to the parent function. So one thing I want to say about this graph is it's decreasing, whereas the parent function is increasing. So if I had to describe a difference, one difference would be that the graph is decreasing. Another difference is that this graph has the parent function has a y-intercept of 0, but this one translated up 1, 2, 3, 4, 5, 6, 7 units. So this translated up 7 units from the parent function. And in addition, this is steeper. So I would say this is steeper than the parent function y equals x, or f of x equals x. We're going to talk more about these, but as you do your homework tonight, in addition to graphing the function with the table, I want you to graph the parent function and decide, is it translated up or down at all? And is it steeper or less steep than the parent function? Okay? Go ahead and get started on the homework.